Hi everyone, in this lesson we'll be going over lesson 17, Intercepts of Linear Equations. So we've been graphing these lines, these linear functions so far this unit, and today we're going to talk about two important features that show up when you're graphing a line. So the two things are called the x-intercepts and the y-intercepts. Okay, so the x-intercept is where the line, or the linear equation, crosses the x-axis, and the y-intercept is where the linear equation crosses the y-axis. So in this example, we're going to look at this line right here, okay, and we want to see where the line crosses the x-axis. So this is my x-axis, this is my y-axis. Okay, so you want to see where the axis and the line cross. Your eye should go to this point right here at the 4, okay, and we name it by the entire coordinate 4, 0. Okay, and then we want to look at the y-intercept. So we look at the y-axis, and where the y-axis and this line intersect or meet. So your eye should go to this point right here at the 3, and we name it by the entire coordinate 0, 3. Okay, easy peasy, right? So let's take a look at number 2. I want you to write down the x and the y-intercept. Okay, for the x-intercept, your eye should have gone to this point right here at the -8, so we have -8, 0. And this is actually the y-intercept, so your eye should have gone to this point right here at the 0, 4. Okay, let's take a look at number 3. What is the x-intercept of this line? Hopefully your eyes went to this point at the 6, so we have 6, 0. Okay. And the y-intercept, where does this line cross the y-axis? Here's the y-axis, here's the line. Do they cross? No, they're parallel, so we can say none. Okay. A line might not have an x-intercept or y-intercept if it's a vertical or horizontal line. Okay, so before we turn the page, let's just take a look at the x-intercepts. Hopefully we notice that the y values are all zeros. Anytime you have a point on the x-axis, the y value is going to be 0. So we're going to use that on the next page. Anytime you have a y-intercept, so on the y-axis, the x values are 0. See, this is a 0 and this is a 0. So we're going to use it on the next page when we find intercepts algebraically. Okay, so for x-intercepts, we know that every point on the x-axis can be written in the form x, 0. Okay, so we're going to use that by substituting y equals 0 into the equation. And the same goes for the y-intercepts. We know there are the points 0, y. The x value is always 0, so we can substitute x equals 0 in order to find the y-intercept. Okay, so let's take a look at example 4. We're going to use this equation to find the x and the y-intercept. So we could rearrange and graph this like we did in the last lesson, but we're trying to do this algebraically, so we're trying to do it without actually having to graph it. So we start with the original equation, 3x minus 2y equals 12, and since we're looking for the x-intercept, we're looking for some x value, 0. I don't know the x value yet, but I do know the y value, so I can go ahead and plug in or substitute 0 for the y in this equation. So we have 3x minus 2 times 0 equals 12. Well, what is 2 times 0? 0. So we have 3x minus 0 equals 12. And then we have a two-step equation we can solve. We'd add 0 to both sides. You get 3x equals 12. Divide by 3, and x equals 4. So that means that this line, if you were to graph it, would cross the x-axis at 4, 0. Let's take a look and see where it would cross the y-axis. Okay, start with the original equation again. Okay, we know it's going to cross at 0, something. Okay, I'm looking for the y, but I know that the x is 0, so I can go ahead and substitute x and 0. So 3 times 0 minus 2y equals 12. Well, what is 3 times 0? 0. Minus 2y equals 12. So I have negative 2y equals 12. Divide by negative 2, and y equals negative 6. That means that this line would cross the y-axis at 0, negative 6. Okay, so that means if you wanted to graph this line, it would cross at the x-axis at 4, 0, and it would cross the y-axis at 1, 2, 3, 4, 5, negative 6. So you could sketch a picture of your line using these 2 points. Okay, let's take a look at example 5. We have the equation y equals 7x plus 3. And first we want to find the x-intercept. So we know it's going to be something, 0. So I'm going to go ahead, since this is x and y, I'm going to plug 0 in for y. So 0 equals 7 times x plus 3. I want you to go ahead and solve for x. Hopefully you did minus 3 minus 3. Negative 3 equals 7x. Divide by 7. And if you plug this into your calculator, you get kind of an icky decimal, so we're just going to leave it as x equals negative 3 over 7. And then when we write it as a point, I'm going to just rewrite this so it's not a line over a line. Negative 3 over 7, comma, 0. So it would cross as a fraction, but that's okay. It happens. Okay, now let's find the y-intercept. So I'm going to rewrite the original equation again. And I know it's going to cross at 0, comma something, right? I know the x value is 0. I'm looking for the y value. So I want you to go ahead and replace the x with the number 0 and solve for y. Okay, hopefully you did this. 7 times 0 plus 3, and then 7 times 0 is 0, plus 3 is 3. So it would cross at the point 0, comma 3. So again, if you want to sketch this line, it would cross the x-axis, here's negative 1, at negative 3/7, and it would cross the y-axis at 0, 3. So you'd have a line that looks like that. Okay, I want you to go ahead and try example number 6. It says from the regions, this is an old multiple choice regions question, 2 points, the value of the x-intercept for the graph of 4x minus 5y equals 40. Okay, I'm going to go ahead and write my equation over here. I'm looking for the x-intercept, right? So since I'm solving for x, I must know y. It's got to be x, comma, 0. So I'm going to go ahead and plug in 0 for y. Okay, 4x minus 0, right? 5 times 0 is 0, equals 40. Okay, and then go ahead and solve for x. Plus 0, 4x equals 40. Divide by 4. And x equals 10. Hopefully you got x equals 10. All right, let us know if you have any questions, and have a great day. We'll see you tomorrow.